After the meshing process, we complete the simulation setup in Altair SimLab with the definition of connectors, contacts, loads, boundary conditions, and solver settings. Bolt connectors can be realized manually or even fully automatically. We can create 1D bolts based on bars and RBE elements, choosing one of the many templates available for both heads and threads. Also, if we decide to go for a solid model of the bolts, we can count on different parametrical templates to generate hex or tet bolts. In our example, having applied mesh controls on the washer faces and on the thread holes, we can let SimLab generate the hex bolts fully automatically. We can simply select the faces corresponding to heads and threads and let SimLab create a solid bolt with congruent mesh. The coincident mesh will guarantee the convergence of the contacts. SimLab already created also a pretension cut for each bolt. We can easily select the group with the pretension faces to add all pretension loads at once. We start the contact creation by defining or importing the surface interaction that we need, for example friction in case of a nonlinear load case. When creating the contacts, it is not necessary to pick the single contact faces. SimLab can also look for adjacent areas among selected bodies. Then we can choose the solver we want to use to enter the solver-specific options. In our example, we start defining a tie contact on the cylindrical faces between the bolts threads and the gear case. Then, we create a planar slide contact with friction between the bolt heads and the cover. Finally, we define the contact between all other components. The created contacts, including all options, can be exported as a template to be recreated automatically on any other assembly using the same body names. In case of a linear analysis, you also have the possibility to assemble the different components without using contacts, just by joining them through a coincident mesh with shared nodes. This can reduce considerably the computation time. We can now proceed with the definition of all other connectors, loads, and boundary conditions. It is possible to define all kinds of structural and thermal loads, if needed also time or frequency dependent. The mapping tool allows to generate loads from the result of a previous simulation. Specific load definitions for powertrain applications are available in the advanced menus. The defined LBCs can finally be included into load cases with all additional options for the solver of your choice. Similarly to what we did with the mesh controls, also LBCs and load cases can be exported as templates, which can be reused on the next jobs or recorded into scripts. Materials, even non-linear or non-isotropic, can be imported, exported, and managed with a database. Properties are used to assign materials and solver-specific element types to the different bodies. Finally, we can select the solver settings and export the solver deck. If something is missing, for example, if load cases or properties are not defined for some component, SimLab can add the missing information before exporting the deck. The path of the solver executable can be specified during the installation, so that we are also able to run the simulation without leaving the modeling environment. In our case, we run the OptiStruct linear analysis directly in SimLab, and we wait for the results to be displayed. Once the solver is finished, SimLab loads the results directly on the meshed model. Pre- and post-processing take place just in the same environment, so that you can verify your modeling choices at any time while looking at the results. The results module offers all basic tools for the post-processing, like contouring of scalars and vectors, animation, queries, hotspots, and table plots, but also advanced tools like derived results, stress resultants, and computation of valve seat and bore distortion. In addition to this, for very advanced or automated post-processing tasks, the SimLab user can count also on the dedicated tools of the HyperWorks suite, like HyperView and HyperGraph.